8, 7. Okay, polynomials. Oh, you guys are loud today. Bring it in. You didn't have pre-calc yesterday. Oh. I already answered that question. Yeah, I noticed. Simmer down. Simmer down. I already answered that question. And I've already said I've already answered that question 3 times now. Okay. Polynomials. So, last chapter, let's see, chapter 1 was linear functions, then we studied systems of linears in chapter 2. Chapter 3 was families of functions, so you got a big picture of many different types of functions. We're going to go into specifics on each of those types of functions the rest of the year. So we're basically taking chapter 3, and we're going to dig a really deep hole for each one of those and fill it up with a bunch of stuff. Okay, so polynomials, anybody give me an example?
Square.
Okay, what does that look like? Okay, here's one parent function polynomial. What's another one?
Absolute value.
That's not a polynomial.
I love you.
Thank you for saying that, though. Now we know. Okay, anybody else? Nope, that's not a polynomial.
1 over x.
Nope, that's not a polynomial.
X. Y equals x.
Okay.
Oh, that's right.
X.
What do you notice is the same on all these?
X, y,
1 over
x.
x.
What similarities are there?
They all have y. They repeat.
Okay, they all have y, thank you. So do all of our equations.
You're welcome.
I'll have an equal sign too.
They're all
Seriously.
They're all infinite.
What do you notice about these?
No, they don't.
They all have
They have all of x.
They all have an exponent, right?
X.
X. And is the exponent fraction? It's all whole number exponents.
Wait, what is the difference between x?
Okay, greater than 0.
What's the difference between x to the 4th and x to the 2nd?
X to the 4th will go, the end behavior of x to the 4th, basically if I were to lay them on top of each other, x to the 4th would just increase faster.
Okay.
Okay, but x squared will not change this shape from a u or a, you know, an arch. X to the 4th can look like this when we start to add cubics and squares in there. There was actually one of those on your test. It was an M. And we asked about absolute max and mins and increasing and decreasing behavior. Okay. You can go. You can keep going. Okay, we can head into x to the 5th. Okay, it's going to look like this as well, the parent function. Okay, yeah, and you can keep going. x6, x7, x8. You can. I mean, there's an infinite number of polynomials. Okay, it's on. One thing to notice, x cubed can do this, right? How many humps does that? Two, right? How many can this one have?
5.
No, you're close.
4.
4. See, this has 2 of them because it's a cubic. This might have 4 of them. So what you're going to look at is maybe doing this. Okay. So yeah, they look the same. The parent function's very similar, but you can start to get some differences in here when I would do something like x 5th minus x to the 4th plus x cubed minus x squared plus x. Okay, so we're adding variables in here. I'm not going to ask you to graph that by hand. It's going to be a calculator problem. Okay, not a big deal. But so those are polynomial graphs. Okay. what we're going to study this chapter is x-intercepts. Does anybody know any other names for those? Okay, 0. What did you say, Brandon? Yeah, 0. Any other names? Okay, there is another one. Root. X-intercept,
Can't
0,
you do that, like
root.
factoring it out and then like?
Yeah, these are all the same thing.
Yeah.
The only difference is this one's graphical. Okay, this one's going to be algebraic. And this one's going to be used with an equation, and it's algebraic still. So know that those terms all mean the same thing. Okay. How many zeros are here? 1, 2, 3. How many x-intercepts are there? 1, 2, 3, right? Just get those three terms in your head that you're calculating the same thing. Okay. So, polynomials. What is the degree of each of these polynomials?
2, 3, 1.
Degree is 2, 3,
1.
that's 1. Okay, what about that one? Yeah, this is degree 5 because it's the highest exponent. Okay. So, why is degree important? Micah? I want to sell that on eBay.
How many zeros though?
Yeah, this degree tells it's called the, here's where we have a lot of fun in math. It's called the fundamental theorem of algebra. We just can't help not including that word. Okay. That is the number of possible, okay, the degree is the number of possible real zeros. Okay. Now, why do I have to put that there? Okay. This graph here, this red one, how many real zeros does it have? 5. But what if I did a little translation and I shifted it to look like this? How many real zeros are there? 1. Gut punch. Okay, so that is the number of possible real number zeros. It doesn't mean that it has to have 5. It can have up to 5. Okay.
So, like, if it looks like the graph looks like that, you still say 5?
This?
Yeah.
Well, if you just are given the equation, you would say there are 5 possible real zeros. But then you could go calculate it and say there is 1, right? So be aware of that. The thing about the fundamental theorem of algebra is that it goes into what are called complex numbers. Okay, so the degree is actually the number of complex zeros. Do you know what a complex number is? This page is getting messy. Complex number? No? Okay. Do you know what an imaginary number is? I, right? Okay, a complex number is a real number plus an imaginary number. Okay. So this function here would have 1 real zero and 4 complex. I'm not going to require you to figure out those complex zeros. That's purely informational. This is all you need to know. Okay, so the fundamental theorem of algebra actually says this: the number of complex zeros matches the degree. Just be aware that the real number of zeros might be less than that. Okay. Should I put one more item on there? No, let's move on. Are you good with all that? There's a lot of info there.
Kind of, sort of.
You will be. This is all information that you'll put in your brains.
I think once I start doing
Okay, so what are we looking at here? We got the parent graphs of the polynomials. We've got the degree of a polynomial. We have x-intercept, 0, and root. Those three items. Within the x-intercept, 0, and root, we have the fundamental theorem of algebra that matches degree. Okay. So, okay. What is if I give you a polynomial function, we can identify the degree here, right? So how many possible zeros are there?
3.
Yeah, 3. Number of possible zeros in the real numbers. Okay. Can you guys see that? The green?
Yeah.
Yeah.
What is the leading coefficient? Yeah, 2. It goes with the highest exponent, with, okay? So if I write something like y equals x plus 3x squared, what's the leading coefficient? 3, because it goes with the degree. Okay. So keep that in mind. Leading coefficient is 3 and degree is 2. So always looking at that. Okay. All right. You know how to evaluate functions, I think, right? Right? Whoa. Let it go, man. We'll blow a gasket. A polynomial of least degree roots 2. Oh, that's 4i. Any ideas? What do you need to? No? Okay, this is pretty straightforward. You're going to write an equation in so you have a 2, a 4i, and a minus 4i, right? All you need to do is put your x's here. Okay.
So, did I say
Like you
not?
don't want to write these
Did
down.
I say not?
What?
Did I say not?
Roots. See, that's that word.
Yeah.
Roots.
So this is imaginary.
Oh, you know what? Let's change this one. Minus. It's always x minus. Right, so you're always going to have the pattern x minus. The only time that's going to change is if you have a negative, and that's what comes in here. Okay, so if you're matching these up, that factor gives us that root. Okay. This factor gives us this root. And there. Okay. It's pretty straightforward. This is factored form. You are going to learn 6 ways to factor polynomials the next few weeks, I think. Maybe more. Okay, so we are going to, right now you could probably FOIL this all together to make a polynomial, right?
Yeah.
During this chapter, we're going to learn how to unpack those into this factored form too. So we're going to go both directions. Okay. So let's finish this one up by distributing. Okay. I just leave this one alone for now. Or you can leave this one alone. What do you care? It doesn't matter. Okay. Just pick one and set aside. FOIL these out. Outers. Right? Inners. Plus, minus. And bring that one with you.
Wait, why is it a minus 2?
Minus 2x.
Well,
Inners.
why is it a minus 2 if it doesn't say the root is a negative?
The root's 2.
The
That
roots are
means,
the opposite.
so the roots come from x equaling 2. Okay, so x is 2. If I subtract this 2 around, I get x minus 2 equals 0. That is what needs to be right there. That's why.
Because you're looking for the 0, so you have to find what makes that function.
Yeah, what makes this 0? If I plug 2 in here, this has to be 0. Yeah. Okay. Now when we get to these, how do I FOIL that together? Just do it?
Yeah, just go for it.
All right, this term has to be multiplied into each of these. And that term has to be multiplied into each as well. Then we'll combine like terms. Okay. And hopefully we don't have any i's left. Okay, that's the first one. Eh, not really. And then plus 8 and okay, yeah, that's a mess, but yeah, they take a while. But you know what, any problem you're going to run into in your career probably going to take a while too, so get used to solving complex problems.
What would it be? Minus 4ix squared.
Which, here?
No, the red, yeah.
Minus 4i x squared. Yep. Yep, remember, keep an eye on me. Do that stuff all the time.
It's gonna be like,
Okay, are there any other x cubes?
Wait, why is the x outside of the square root of negative 16i squared?
What?
Like, in the red, you have 16i squared. And
Because
then
the
x
I is multiplied with another I with negative 4i.
4i. And 4i is
So the I would
16i
be
squared.
So the x has to be on the outside of the square?
It does, yes, there's only one x. Right. that's only x. There's I times I, which is I squared. Are there any of those ix squareds? There's another one. Oh, look at that. Positive 4 and negative 4 of them. Okay. How about x squareds? Okay. What about IX's? Oop, how about that? And
So, for the 16 and the 32, would you just subtract 16 from 32?
yeah, 32 minus 16 is plus 16 I squared. Do you know how to deal with I squared?
Yes.
It's negative 1, right? Yeah, so I squared is negative 1. So what we end up with is x cubed minus 2x squared minus 16.
Isn't it like?
What about the x that's on the side? Yeah, on the 16.
Oh, that was,
Uh-huh.
well, somebody said combine those, so I did.
Well, I was asking
Okay,
with the x.
Minus 16x and then minus, then plus 32x.
Scratch that. Yeah. Plus 16x
Minus 32.
Minus, no, yeah, plus 16.
minus 32. Okay, thanks for the correction.
You're welcome.
Thank you for not waiting until I turned the video off this time. That was awesome last time. Okay. So, easy to write the equation, then you got some algebra to do. Do that algebra because it's going to pay dividends, all right? Okay, grab a calculator. I'm going to show you how to find roots on a calculator.
I'm going
It's
spelling.
not optional.
So, how come this becomes plus 69?
16x.
Well, yeah.
So I squared is negative 1.
Well,
I squared
yeah.
is negative 1. So
I didn't
16
finish
times negative 1 is
that
minus
one.
16. Okay. Put that function there in your y equals. All right. So just this is the same method as calculating min or max. Okay. So put that in your y equals screen.
Oh my gosh, it's a long equation.
Freak out about it. Is it good? Graph it. Whoa, that's ugly. Okay, my window's a little funky, right? Do you remember how to fix that? Zoom 6. It'll put you in the standard window. This is where most everything's going to come for us. Okay, can I see the zeros there?
Yeah.
Knowing it's a function to the fourth, This is shaped like a W, and so I've got everything. The zeros are here and here, correct? Okay. This calculation is just like a min or a max. Mr. Jansen, why'd you do that? Okay, so put it back so somebody else gets a word calculator. Nice work. Okay, so we're going to second trace, that's the calculate menu, and now we want to do a 0, right? This menu is kind of important. There's even a calculator portion of the AP Calc exam right there. 6 and 7 are friends. Okay. Again, we're doing left bound and right bound and a guess, right? So if I want to do, oh, I think I messed it. The cursor's not showing up, is it?
No.
Okay, I need to change my window. See, let's see how it's negative 1.7.
Mine's still going down.
Okay, versus
I think it's like
0.9. That should be pretty close, but I can't see it. So you can do this at this point, but I'm going to change the window so you see it better. Let's go to negative 5 and 5. That here too. Okay, it's a little easier to see this time, right? There, okay. So that cursor is to the left of this 0. Hit enter. Now go to the right. Hit enter. You can try to put the cursor on it, or you can just type, I think it's 2. And then it'll give you the 0, it's probably 2. Quit. Well, some screwy. Oh, that was dumb. I made a mistake. Imagine that, right? I should have put negative 2. Thanks for that. Happened last time I tried this. Okay, left bound. There. Right bound there. And I'm going to guess negative 2. That makes more sense. There's my 0. Okay. Which you probably could have looked at and guessed it, right? Some of these are like square root of 2. I'm guessing 1.414 is pretty much outside our human abilities. So that's how you calculate zeros. Do you want me to run you through this one? Okay. Second, calculate a 0. Left bound. I need to go over here. Okay, that would be to the right, so I need to be to the left, to the right, and then I'm going to guess 2. And there's my 0. Okay. That's fine. Anything to the left and the right. The more accurate you can be, the more accurate your answer will be. So that has 2 real zeros. How many complex would it have?
1, 4.
4, but we've already used 2 of them, right? So there are 2 complex roots as well, which we are not going to work on figuring that out yet. Okay? So just keep that in mind. 2 x-intercepts and then 2 complex roots. If you need help on the calculator part there, I can come around after this. Do you have any questions? Today was a lot of information and one little algebra thing. So so the new problems, 5, 7, 9, 11, 13. You got 6 new problems to work on. 7. And then some reviews. Okay? About 15 minutes. Look through them and see if there are any that might confuse you and give them a shot. We're going to have this due tomorrow. How many will be gone tomorrow? Tomorrow's that volleyball tournament with concessions.
We don't.
4. Okay. It's just concessions. Thanks.
How much we're setting up.
That's right. Good deal. Okay. If you are being lazy today, I recommend you don't continue that.